Hey guys, welcome to a presentation on a three-wire motor control circuit, the foundation of all motor controls. Some of the key takeaways from this presentation is what it is, what it does, what is its key components, how it's designed, how it is different from a two-wire control circuit, and lastly, what applications would this circuit be used in. First, as I said, this is a foundation of all motor control circuits. All motor control systems are based on this simple concept. Once you understand this setup, you can build on it by installing timers, multiple start and stops, and other controlling components. First, for those that are not familiar or they're novice, let's answer the question, what is a motor control circuit? Simply put, it's a circuit used to control the functions of an industrial type motor, most commonly used to prevent unexpected starts, which could lead to injury of the associate, the one using the machine, or damage to the machine, such as overheating. So let's start by examining some of the key components of this motor control circuit. All right, guys, some of the key components to a three-wire motor control circuit is going to be the motor. Three-phase. It converts the electrical to the mechanical energy. It's typically a three-phase, as I said, which means it has three sets of windings that are energized in a specific sequence to produce a rotating magnetic field. Next is contactors. Contactors are electrical switches that are used to control the flow of electrical power to the motor. They have two main contacts that open and close to allow or to block the current. Next is overload relays. These relays provide protection from the motor overheating. They're connected in series to the motor, monitoring the current using thermal sensors that once detect a current over a certain threshold will open the circuit and stop the motor, preventing damages. And then you have the start and stop button, which abbreviated will be BP. These are momentary switches that control manually the operation of the motor. Actually, they can also control the flow of the current through the line. Next is the power supply. Of course, you got to have power coming into it. It controls, typically, it's a three-phase power source. The coil, which is a device that stores the energy. And then the control circuit, which controls the operation of the contacts based on the input of the start and stop buttons. So guys, here's what we have with a two-wire de-energized or dormant example. You can see that the stop is in a normally closed and the start is in a normally open. And then you have the coil, and then you have the relays on the right. And you notice that the relays, the overload relays, are in a closed position. So essentially this system, this setup right here is de-energized. It's not receiving anything to the coil. Remember, the coil is what stores the energy or electricity. It shows nothing coming through it. There's nothing from it to the relays. So this is an example of a two-wire de-energized system. Now let's look at it now in an energized state. So here's your two-wire energized example. We can see the difference between this one and the previous slide is the position of the start button. So you got the 110 coming in. Stop button's normally closed, so it's going through, the current's going through there into the start, which now is pushed down. Spring, remember this is spring activated momentary switch. It's pushed down, allowing the current to go into the coil. The coil then sends out the current to the relays, which are normally closed. And again, those relays, as we talked about, the overload relays will stay closed till they sense some maybe a surge or more volts to the machine than the threshold it's designed to accept, and then they will come open. So right here you have the 2-wire energized example. However, when that push button start is when you let go of that, then it de-energized the system, which is not optimal for what we want. That's why we are going to look at the advantage of the 3-wire energized system over the 2-wire. Okay, so here we are. We're at the 3-wire motor control with the auxiliary contact. This is what we're looking for. This is the all-elusive auxiliary contact that's parallel to the start. Now what you see here is a normally closed stop momentary button, normally open start, an auxiliary contact, control circuit that's parallel with the start button, and a de-energized coil and the overload relays. This is the flux of it all, in the difference between the 2-wire and 3-wire. This is really what gives some electricians fits, is what to do with that auxiliary contact. Now, just remember that this auxiliary contact is physically integrated into the coil. Now, let's go and look at the operation of this and how it works in our next slide. Okay, so now here we are getting into the meat and potatoes of this entire circuit. So we still have our stop that is closed, and now we have pushed the start button. Now what has happened is the 110 is now spread across to the coil, which is energized and which also closes the contact at the auxiliary, or closes the contact of the auxiliary that's parallel to the start. So now we have our 3-wire motor control closed example. And now you're probably thinking, how is this different than the 2? Well, remember, we've closed our contact now, that auxiliary contact that's integrated into that coil. So let's move on and see what happens when we let loose of that start button. Alright guys, so here's our ladder logic with the start button released. Notice that the difference between this and the 2-wire that we showed earlier is that I have a closed contact that's parallel to the start that continues to allow the electricity to flow through that contact, of course through the stop that's normally closed, and into the coil, energizing it and letting the electricity run on through the motor. So this is the flux of the difference between the 2 and the 3-wire. Now, how do we stop this? How do we de-energize this circuit? We're going to show that next for you. Okay guys, now here is what is also called as the low voltage protection. In order to stop that electricity or that current from running through the circuit, we had to manipulate the stop button, and that breaks the contact and also breaks the auxiliary from being closed. It opens it, and then the whole system's de-energized. This is called the LVP, and this is what we're looking for. This is the main difference between the 2 and the 3-wire. Now, I cannot just hit the stop button and re-energize the system. It has to be completely done over again, and we're looking at having to push the stop and push the start to re-energize the coil that then will close the auxiliary contact. So this is it. This is what we're looking for. Now, to wrap up this presentation, what I'd like to do is go into more depth on the key components. And then lastly, to wrap this presentation up, I'm going to show you an application, a machine that this is used in. and we'll go from there. Okay, guys, so here is a large industrial motor. It's comes on this machine. It's a wire feeder and roller. You can see the start-stop button on the right side of it. You can also see the power supply coming in. This was, as it says there, was delivered with the self-contained motors and controls. So this is an example of the 3-wire start-stop control, motor control here. I think that we need to maybe recap some of the key components, some of the what the variations are, the 2-line and the 3-line. So let's go to the next slide, and I'm also going to give you some pictorials and actually show it to you what it would look like in a real life setting, and then we'll go from there. Okay, guys, so it's always better to actually see the components pictorially. So what we have here is a 3-phase motor control wiring tutorial. As you can see, you've got a stop button on the left there, normally closed, and then the start button normally open, as I've shown you in the previous diagrams. Now, I did not show you the circuit breaker, which is basically it's a fault system that it puts in there that you can, if it's overloaded, it breaks, kind of like the overload relays. Also, you have there's your connectors, and there's your thermal overloads there at the bottom, as you can see. And then there's the 3-phase motor. That's what this is what it's all about, is controlling that motor essentially through the switches. So let's kind of go over and summarize what we've learned in our next slide. Again, this is the foundation of all 3-wire motor control circuits. And let's go and let's talk about what we've learned. Okay, let's kind of summarize what we learned. We went through the foundation of all motor controls, which is the 3-wire motor control circuit. What it does, it essentially controls the motor. And it's all about switching, using switches to control the circuit, how you want the circuit to close, how you want it to open, how you want the motor to be controlled, essentially. And then once you learn this, you can actually add to your circuitry timers that will allow it to open and close at a certain time, and be able to control it in a time interval. And all motor controls are based on this system, so it's something we need to learn. And it controls the large industrial motors. And we talked about the key components that are part of that circuit, which is, of course, the motor and the contacts. You got to normally open and normally close contact. And if you remember that when we went from the 2 to the 3, we actually was able to add an auxiliary contact there parallel to the start button. And overload relays, we talked about those. How they are built in, and they monitor the thermal value of the circuitry, and to see if it exceeds a certain threshold, then of course they open up and they break that energy, and that system becomes de-energized. And one of the most essential is your momentary start and stop buttons. And essentially that's what we're doing. We're controlling this motor through these switches. Then you have the control circuit, or that auxiliary contact that we talked about. And of course, last but not least, you have your power supply. Okay, so I hope you understand a little bit more about the three-wire motor control circuit, and we'll see you in class.